Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 22 of the subject of software quality engineering, in which we are going to discuss software quality metrics part 1, and here in this part we are discussing the introduction to the measurements. Dear students, measurement is very much important for software quality. When we measure some things, we can easily assess the quality of the product. When we cannot measure, then we cannot assess the quality of the software development product. So here in this lecture, we are introducing different measurement techniques that will be used to assess the software quality. This is the discussion agenda. It contains the topics of the measurement, measures and the metrics. And then we have what to measure. Then we have the types of measurements including the process metrics, project metrics and the product metrics. Then why do we measure? Here we will discuss reasons of the measurements and examples of the metrics usage, that where these measurements will be used. Then we have IEEE, that is Institute of Electrical and Electronics Engineering, definition of the software quality metrics. And at the end, we have the main objective of software quality metrics. So, it is an important proverb that if you cannot measure something, you cannot manage it. This is, in fact, provided by the Tom DeMarco in 1982. And if something is measurable, you can easily manage that particular entity or a product. So measurement is very much important for managing it. For example, if you have a road and you cannot measure that road, so how you can manage the development of that particular road? In fact, you cannot present the progress of the development for that road construction. Similarly, a student has a marks in the exam. So that marks is in fact used to measure the skills of the students. So if you have a good measurement techniques, you can represent that particular entity in a very good manners. So that's why measurement is very much important for us. Now these are another important codes for the measurements. First quote is that if you want to know, then you have to measure. When you can express what you are speaking about and you express it in numbers, you know some things about it, but when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager kinds. And that is spoken by the William Thomson's Lord Kelvin physicist. So basically, if we cannot measure some things, we cannot express that particular entity. For example, we cannot measure the soil. Soil means that if everyone has a soil, when he dies or she dies, then the soils exist. So we cannot measure any characteristics about that particular human behavior. So for example, we cannot measure the death, we cannot measure the soil. Similarly, we also cannot, in fact, measure something quantitative things, for example, the beauty. So, if we cannot measure anything, we cannot express that particular things, that how we have information about that particular entity. So, when we measure some things, our knowledge about that particular product or entity is of very important for us, and based on that particular measurement we can express the entity. For example, we can measure the temperature. Today is very cold day, so that's why I'm saying that it is cold, because the temperature today is about 15 degrees Celsius. But when in the summer temperatures in fact goes to 45 degrees Celsius or 50 degrees Celsius, we say that is very hot day today, because based on certain Celsius measurements we can express the temperature of the daily life. There is also another proverb at the quotes, and the quote is, but make sure you know what you are measuring. So we have to make sure that what we are measuring, the measurement should be exact and correct. So in truth, a good case could be made if your knowledge is meager and unsatisfactory. The last things in the world you should do is to make the measurements. And the chance is negligible when you will measure the right things accidentally. So basically, the measurement should be very much satisfactory and correct. If the measurement is unsatisfactory, then we have to remeasure that particular things, and we have to perform a good measurements. And if the chance is negligible that you have measured the right things accidentally, then we says that that measurements is in fact very important, and we have to do exact measurements. And that proverbs is provided by the George M. Miller's physiologist. So psychologist is a person that George A. Miller was a psychologist, that he says that we have to make sure that what we are measuring is very much important for us. Now, there is the little bit difference or similarities between measurement, measures, and the matrix. What is the measurement? Measurement is the act of obtaining a measure. Basically, measurement provides us a technique for measuring. So when we measure some things, in fact, we are performing the measurements. For example, we are measuring the distance in kilometers. And how we are measuring the distance in kilometers? Using certain skills or certain tools. Now, measure is in fact provides a quantitative indications of the size of some products or the process attributes. For example, number of errors. Basically, measure provides a certain quantitative informations. Like, for example, line of code is a measure. Similarly, people per person hours work is also a measurement. Number of errors or defects in a program is also the measurements. So measures is in fact a quantitative values that represents particular size of the product or the process attributes. Attributes may be, for example, when we measure the efficiency, we says that this software is very much efficient because it performs the task 20 tasks per seconds, for example. So that means that measuring the efficiency of the software is depends on the number of tasks performed per unit times. Now, matrix is mostly used in the software engineering, and matrix also represents the measurements. So it is a quantitative measures of the degree to which a systems, that is the products or the components, that means that some units in the softwares or the process, means that, for example, life cycle, development cycle process which is used to develop the softwares, and this possesses a given attributes, means that we have to find out the attributes of the system component or processes, and we have to measure the attributes of the systems components or the process, and that is called the matrix. This is the IEEE software engineering standard 1993 attributes, also the software quality attributes. For example, here the matrix means number of errors found per person's hours expended. So in the 1 hours, how many errors are found by the person in the software system. So when we identify certain errors, bugs or defects in our systems, we have to expend the number of per person's hours on identification of the errors. So how many errors are identified, that is represented with the help of the matrix here. An important question arises that what attributes should we measure? There are three main measurements we have to perform. First one is called the process measurement. As its name indicates, in the process measurements, we measure the efficiency of a process. Here, we measure the efficiency or effectiveness of a process. As you know that the process is in fact the step-by-step technique used to develop the software systems. For example, we have the waterfall models, which is a life cycle development process. Similarly, we have the iterative enhancement models, and we have the spirals models. All these models are called the life cycle process models, and these are used to develop the softwares. Now, in the process, mostly we measure the work performed for the development of the project. So we measure the effectiveness of the process here, that what work has been performed and what should does not or what doesn't has been performed here. The second important things that we are going to measure in the software quality is called the project. In the projects, we assess the status of the projects. The project, for example, we trace that the number of risks that are occurring in the project, or we identify some problems in the project, and we measure that particular problems using the matrices. So we adjust the workflow when we have to identify the problems, then we adjust the workflow, and we have to find out that by this way the project will be completed in the successful manners. So we measure different attributes of the projects. Attributes includes different sort of the risks that are encountering in the projects. Similarly, the attributes means that different progress that has been made while this project is in a continuous state. So in the project matrix, we measure the progress of the projects, that how many tasks has been completed when this project is in fact in the continuously work state. The third measurement is called the product matrix. In the product matrix, we measure predefined product attributes. So here, the predefined means that all these attributes which are specified in the software requirement specification documents. In the product matrix, we measure different attributes relevant to the products, for example, efficiency, security, maintainability, usability. All these attributes are properly measured. For example, if you want to measure the usability attributes of the project, so then we will provide the product to the end users, and we will monitor that how many tasks has been performed in 1 hour or in the particular unit of time. So in the product matrix, we measure different attributes that are relevant with the product. Now first we will define all these three different measurements in the details. First one is called the process matrix. In the process matrix, we measure the efficiency of the process, that what work has been performed and what work is not performed yet. In the process matrix, we measure, for example, code quality. Code quality which means that the implementation quality of the software project. Similarly, we measure the programmer productivity, that is the number of tasks completed by the programmer or the number of the functions implemented by the programmers. Similarly, we measure software engineer productivity, that means that the productivity of the software development engineer for this current projects. Now, there are multiple people working as a software engineer for the productivity, which includes the requirement analyst. The requirement analyst is responsible for performing the requirements or eliciting requirements from the customers. Now here we will measure how many requirements has been successfully elicited and documented by the requirement engineers. Similarly, designers is responsible for designing. Here we will measure how many items or how many components has been designed by the designers. Maybe that may be the database designing or the unified modeling language design, that is the UML designs, or the graphics designs as well. In the testings, we will measure that how many test cases are created and how many tests are performed here. So all these things are measured and the other tasks done by the software engineers are also measured. Similarly, in the process matrix, we also measure the software itself. Software itself means the different attributes relevant to the software, including maintainability, usability, and all other quality factors, for example, portability, efficiency, security, etc. So all these attributes are measured using the softwares. Similarly, we also perform management measurements for the process matrix. The manager is responsible for different tasks including cost estimation, schedule estimations, risk management. Similarly, manager is responsible for the staff selection and staff training as well. Also, manager is responsible for report writing and report presentation. So, management measurement includes cost estimation, means that the budget required to complete the project that is estimated by the manager. Similarly, schedule estimation, that is the time required to complete the project, including duration, time, and similarly the staffing. Staffing means the human resources that will be required to complete the project. If the human resource is not available, then we will use the freelancing or outsourcing so that we can hire the distance software developers. So we will in fact identify different sort of the activities that are relevant with the project manager, and we have to measure all these, and these measurements are the parts of the process measurements. Now measurements are the process metrics include the overall development time, that is the also the type of methodology used. So overall development time is the time schedule of the software development, and the types of methodology used is also measured using the process matrix. Methodology may be, for example, object oriented methodology, similarly function oriented methodology. All these are methodologies. So here we will measure the process matrix using the development times and the methodology used to develop the software systems. The process matrix is in fact the collected all over the project and over a long period of time. So because the process takes at least few months to some years, for example, the project may last up to 5 years when the project is has so many modules, then it can be expanded up to 5 years or more. So that's why the process matrix is also collected over a long period of time. So the intent is to provide indicators that leads to long-term software process improvements. That's why process matrix is very much important. When we have to perform the software process improvements, then we have to measure the each and every steps involved in the software development lifecycle process model. After the process matrix, we have to measure the project matrix as well. In the project matrix, we usually measure how project manager can estimate the schedule and cost of the project. So here, the project manager is responsible for measuring the project, as it is a key responsibility of a project manager to measure the project matrix, because there are two important measurements in the project matrix, which includes the development time and the product cost. Usually, the project manager measures the project matrix to minimize the development times, and it just means necessary to avoid any sort of the delays and potential problems and other risks that can occur in the project. So the project manager is responsible to measure the development times and also in fact to resolve the certain delays and potential problems in the project. And the main problem is the risk. Risks are certain factors which can affect the quality, cost or schedule of the project. For example, staff turnover is one of the risks and which can delay the project. Also, the requirements unavailability is another risk which can also delay the project. So that's why development time may be over long. So just to avoid the delay, we have to identify different sort of the risks that can affect the quality, cost and schedule of the project. And also the project manager is responsible to measure the product costs. The product cost is the estimations of the project manager, which means the budget required to complete the project. So the product cost on ongoing basis, and also the project manager is responsible to make the necessary modifications, and the project managers will in fact perform the re-estimation of the cost that will occur on the project. So these are very much important measurements which in fact make a project very much successful. Also, it can lead to the successful business of the development organization. Next measurement after the process and the project metric is the product matrix. As its name indicates, here we will measure the quality attributes of the product. The quality attributes are those attributes which makes the product very much successful. So here we measure the software products and any stage of the software development from the requirements to the installed system. That means that we will measure the product attributes from the first stage, that is the requirement analysis, until the final stage, that is the installations or the deployment phase. So the product matrix measures different attributes of the products. It includes how to use the softwares very easily, means that the usability matrix has. Also, it is used to measure the maintenance of the softwares. Here we will perform maintenance of the maintainability matrix, and also the product matrix measure the quality of the software documentations. That means that different documents involved in the software development, including software requirements specification document, that is the SRS, or the software design description documents, that is the SDD documents. Similarly, we have different testing documents or the test cases or use cases. So all these in fact measurements are performed using the product matrix. Now, why do we make the measurements? Measurement is very much important for the quality. So, to determine the quality of a piece of the software or documentations, we require the measurements. If we cannot express some things in numbers, we cannot determine the quality of the products. Also, we cannot determine that if the number of pages produced in documentations are larger, then we can say that the size of the software is also very much large. So that means the big software also always requires large number of pages in the documentations. Maybe includes the software requirement specification documents, software design description documents. Similarly, uh, uh, test cases documents all are very much important for the software quality. So it also determines the quality work of the people such as the software engineers, programmers, database administrator, and mostly importantly the managers. Basically, when we have to measure the productivity of the software development organization, we have to measure the quality work of the people. So when we measure the quality work of the people, then it says that our organization is of the high standard. So it improves the quality of the products, project, and the process mainly. So that's why measurement is very much important if you want to improve the quality of the product, the project, and the process, and most importantly, the honor of the development organization, because the honor of the development organization depends on the product, project, and the process. Also, measurement is used to assess the benefits which is derived from the new software engineering methods and tools. Dear students, we have different methods used for the software development. For example, object-oriented methodology is one of the method here. And it is in fact the refinement of the procedural languages. So then we have to switch over the objects and classes, because by using the object-oriented methodology, our development will be very much efficient. So because the objects are used to encapsulate both data and member functions, and we can reuse the objects in many times in other places or in other codes of the software development. So that's why the object-oriented methodology is much efficient than the procedural languages or others sequential languages or sequential development. Also, the measurement is used to assess the quality of the tools as well. For example, if you are using C++ for the software development, automatically your development efforts will be in fact degraded here. And if you are using Java or the Visual C Sharp.net, that is the most advanced languages in the software development, then automatically the software's development's productivity will be improved for the organization. So methods and tools quality depends on the good assessment. Now how we will assess that this method or this tool is much better than the previous tools. So here we will measure that what sort of the help is available for this particular methodology and tools, and similarly we also make measurements that how many classes or packages are available for this particular tools. For example, we have JBuilder in for the Java. Similarly, we have Eclipse IDE for the Java as well. These two are different tools. So for the Java language, but the Eclipse is most advanced than the JBuilder. So that's why, because the JBuilder, the Eclipse provides more packages and libraries for the development. So that's why we can say that the Eclipse IDE is much better than the JBuilders, because here we perform the efficient software development. Also, the measurements is used to close the gap of any problem, for example, the training. So when we identify certain measurements for the different attributes of the products or the project or the process, then we can say that it identifies the gaps, the any problems here. For example, when we say that the software engineers software development productivity is not good and we want to improve it, so that's why the training will be required here. So how you will identify that the training is required, because you will measure that the number of components produced by the software developers per person hour. So here you will measure the productivity of the software engineers. Also, the measurements helps to justify requests for the new tools or additional trainings. So based on certain measurements, the top managers will decide that whether it is the times to recruit the new tools or the additional trainings for this for the software engineers. For example, day by day the software technology is advancing, so that's why additional tools and training is required for the software engineers so that their skills will be developed. Now, there are many examples of the metrics usage. So basically, the metrics are used to measure the estimation skills of the project manager. As earlier we have explained that it is used to enhance the schedules and budget assessments of the project manager. Similarly, the metrics are also used to measure the software engineer's requirement analysis design skills here. That means the process matrix is here, and the process matrix performs the assessment about the requirement, assessment about the analysis of the requirements, and also it assesses the designs of the software development so that the high quality products is developed. Also, measurements performs the programmer's work quality. Programmer's work quality means that the measurements is responsible for the high quality code produced by the software's programmers. Similarly, the measures also improves the testing quality of the software quality assurance personnel. The testing is very much important in the software's quality, because testing identified the different bugs, defects and errors in the software's products. So that's why testing should be performed very much carefully and the good metrics for the software testing should be utilized. Now, before going towards the software quality metrics, we have to identify or we have to understand the international definitions of the software quality metrics. This is the Institute of Electrical and Electronics Engineering definition of the software quality metrics. Number one, quantitative measure of the degree to which an item possesses a given quality attributes. Basically, the measurement provides the quantitative measurement. That means that it can be expressed in some numbers, for example, 10, 20 or 50. For example, we says that the line of code of this program is 2000 lines. So we can say that this is the quantitative measurement of the software. So here the quantitative measurement is used to represent the quality attributes of the software systems, and the quality attributes may be, for example, the security. We can measure the security that per day 2000 attacks were identified or they are in fact occurred, and only two attacks have successfully attacked the database, while 1998 attacks are repelled here. So basically the quantitative measurement represents that the quality attributes of the software products. Also, the IEEE definition says that a function whose inputs are the software data and whose output is a single numerical values means that the matrix is computed over a software's data. Software data includes, for example, the source code, similarly the number of components in the software, similarly the number of database files or the tables in the software, similarly different files and other images etc. in the software systems, and these were act as an input for the measurements. While after performing the measurements we will get a single numerical value, and that value can be interpreted as the degree to which the software processes a given quality attributes, and from that particular values we can identify that the quality of the software project. Now, main objective of software quality metrics. The main objective is to facilitate the management controls, also performing the planning and managerial interventions, and that is the based on deviation of the actual from the planned performance, also deviation of the actual timetable and the budget and the performance from the plan. So means that software measurements is used to facilitate the managers who is responsible for controlling, planning and managerial interventions. And these are in fact performed by computing the performance of the software development. Means that what is a performance of the software engineers for developing the project, and that is in fact the deviation of the actual from the plan. For example, if the actual is very slow and the plan that is the expected is means that it should be in fact that software should be computed until the end of this month, and actually we are in the very beginning, so that means that the software project manager has to control the situations. Similarly, deviation of the actual timetable and the budget. So here we will manage that the actual timetable and the budget should be controlled here. If we are slipping the timetable or we are over budgeting, then the project manager has to make certain decisions and also has to control the situations. So also the objective of the software quality metric is to identify the situation for the development or the maintenance of the process improvements that is based on preventive or corrective actions. Here, the project manager is responsible for all sort of the developments or the maintenance process improvements. And the process improvement is based on accumulation of the matrix information regarding the performance of the teams and units, etc. So when we have to improve the software process, we have to identify the performance of the teams and different units that are working on the projects. Dear students, this is the end of the lectures. If you want to read more about these topics, you can study these two books. The first book is The Matrix and the Models in the Software Quality Engineers by Stephen H. Kahn, and the second book is Computational Intelligence in the Software Quality Assurance by Scott Dick and Abraham Kendall. This book is very much relevant with these topics. So if you want to read more, you have to study these two books. Also, if you have any questions, you can ask the questions through the email. My email is m.kadim@kust.edu.pk. I will answer your questions as soon as I get your emails. So I will wait for your questions and hope that good quality and high standards questions should be asked here. Thank you very much.